Hey, everybody. Welcome. Is everybody having a great Ignite? Woo! Yeah. A lot of beautiful people in the room right now. Did everybody have a good lunch? Good? All right. Hopefully nobody's sleepy. If not, we'll be able to energize you up. Welcome, everybody, to this talk where we are aiming to take you from zero to Kubernetes with AKS Automatic. Show of hands, how many AKS users in the house right now? OK. How many AKS Automatic users in the house? All right. There we go. You're in the right place. So for those of you that don't know me, my name is 𝗦𝗲𝘀𝗀𝗲𝗓. I'm a cloud-native developer advocate at Microsoft, and I am joined by the wonderful
Wang, and I'm a product manager working on AKS Automatic.
Yeah. So the whole point of this talk is to just show you all the latest innovations that's happening around AKS, and especially AKS Automatic. So let's go ahead and start here. Kubernetes. So Kubernetes, the go-to cloud-native platform for AI and modern apps. But what makes it the go-to cloud-native platform for many organizations? Well, it's declarative API-driven architecture paired with automatic scheduling, self-healing capabilities, and seamless scalability allows teams to iterate on code and keep their services up and running with minimal operational overhead. Now, I know there are folks in the room that's going to argue with me about the minimal operational overhead part, but that's what this talk is for, right? We're here to help you understand how AKS Automatic allows your teams to innovate fast and, most importantly, ship fast to stay ahead of the competition. Now, at the end of the day, in order to innovate fast, what do you need? You need a platform that is highly scalable, resilient, observable, and extensible. And when you couple Kubernetes with Azure, you got all the ingredients that you need to build something special. With AKS, our mission is to empower you to achieve more with Kubernetes. And in short, AKS gives you the best of both worlds. A fully managed integrated service that thrives on community innovation, right? And so driven by two guiding principles of open source innovation and seamless Azure first experience, the AKS team's sole goal is to help you through some of the biggest challenges in running Kubernetes at scale, ranging from capacity, resiliency, security, developer experience, performance, cost optimizations. So let's just double click into this a little bit. AKS is rooted in open source. And for those of you that don't know, Microsoft is actually one of the largest contributors to the Cloud Native Computing Foundation, or the CNCF. And we're proud to say that we actively contribute as we adopt and even donate projects where we see that they will make benefit in the community. And by tying AKS tightly to open source, we bring you the latest community innovation and proven best practices straight into the Azure cloud so that you get faster value, higher confidence, and the freedom to keep all your workloads on the cutting edge. Now, we don't just hand off the product. No, we live it. Each day, our own internal teams actually runs millions of containers on AKS. And it actually powers some of the services that you already know today, like AI augmented search with Bing, Office 365, Teams, Xbox, GitHub Copilot, and many more. And by operating at the same scale that drives the world's largest cloud, we've learned a thing or two about running this stuff at scale. And the insights that we get from both internal and external customers like yourselves, they're invaluable and actually drive the product roadmap. So every patch, every feature, every best practice in AKS just comes directly from everybody that uses it. Now, talking about how awesome Kubernetes is and expecting them to just jump into the deep end isn't very fair. And there's that word again, overhead, right? Kubernetes gives you incredible flexibility, but that power comes with complexity. New teams often just dive right in, sometimes not knowing what they don't know. Misconfigurations multiply, and then day two operations just kind of pile up, and you're just in firefighting, day two operations type mode, right? As clusters grow, observability becomes a concern, security, and then cost control, and we're just always fighting this battle. Now, the reality is that most teams just want Kubernetes, but they need it to be simplified, standardized, and they need a way to run Kubernetes so that they can just focus on building and not so much on managing. And Amanda, we have a solution for this, right?
Yes, we do. So with AKS Automatic, it actually recently became generally available back in September. And you can think of Automatic as a new SKU of AKS that makes getting started on Kubernetes easier. AKS Automatic is production ready by default. This cluster is pre-configured with different features out of the box, so you can get started quickly. These configurations are based on our learnings, supporting first-party and third-party customers at scale. It also has built-in safeguards, so your cluster is not only following best practices when it's created, but as you deploy more workloads, that cluster continue to adhere to the best practices. And AKS Automatic enables you to go from code to Kubernetes in minutes with all of its built-in developer toolings, which we'll talk more about. One thing to note is with AKS Automatic, because it's just another type of AKS cluster, you still have access to the Kubernetes API, where you can fully take advantage of the open source community that makes Kubernetes so powerful with the simplicity and guardrails of a managed service. But don't just take my words for it. Here's what our customers are saying. From the Royal Mail Group in the UK, they mention Automatic has significantly helped them reduce their operational overhead and allowing them to focus their time and energy on developing and deploying their applications rather than managing the Kubernetes infrastructure. So to simplify Kubernetes, we created AKS Automatic, the easiest experience for developers and operators. It comes pre-configured with best practices for networking, compute, security, and observability out of the box, removing the need for you to manage these countless configuration knobs. All of these features that you see on the slide is pre-configured in an AKS Automatic cluster. This means teams can get started quickly without wrestling with the complexity of Kubernetes. So AKS Automatic also includes built-in deployment safeguards that prevent and in some cases resolve problems and misconfigurations that could lead to reliability or security issues. And deployment safeguard is using Azure policy to ensure that as you deploy new workloads, all of those new workloads still adhere to those best practices. And now Paul will show you how to go from code to Kubernetes in minutes.
Cool. So I do have a few demo recordings. I would do it live, but this stuff just takes a while to bake. So let's start the journey at day 0 or day 1, the developer onboarding experience. This is how we could go from code in a GitHub repo straight to an AKS Automatic cluster just within a few clicks. So here I have a sample airline application. Here's the source code over in GitHub, and it's just that. It's just source code. If I click into here, you might have seen a Docker file, but that's basically it. In the Azure portal, you can actually go and create a brand new cluster from your application by clicking on the Deploy Application button. All you need to do is set some basic settings like resource group and the location and point it to your GitHub repository and select the branch. We have an existing Docker file in this case, so we can use that. But if you don't have a Docker file, no worries. It can automatically generate one for you. And so here I'm just setting the build context and then pointing to my Azure Container Registry where that image will be built and sent to. If you don't have Kubernetes manifest, no problem either. You can actually use this feature of AKS to automatically generate that for you. So just pick a spot where you want it to save within your repo and then set some settings over here. You can see that as soon as you click on this settings right here, the best practices when it comes to Kubernetes deployments are kind of baked into it. So like scaling, resource request limits, and things like that, it's all there. From there, you need to point to a cluster. If you don't have a cluster, we can create one for you, and that's what we're doing. And so we're creating an AKS Automatic cluster. You can see that the automatic upgrade scheduler is configured, and Azure RBAC is configured as well out of the box. If you click on the monitoring settings, you literally don't have to click anything. You just click on it and just say, yeah, that's good to go. It'll actually do all that for you. Review some of the changes that it's going to make because you always want to double check. And then take a look at this. The Kubernetes manifest files were automatically generated for you. There's at least maybe a couple hundred lines of YAML that you did not have to write, so that is pretty awesome. And so that deployment will actually go out. It's going to provision the cluster, and then what it's going to do is going to create a pull request inside of your GitHub repo. From that point, you just click on the pull request, review the files that it changed, and you can see here that the first file that I'm looking at is a GitHub workflow. So this is basically your CI/CD process that will automatically build your container image, send it to the ACR, and then actually deploy these Kubernetes manifests into the cluster. All you got to do from that point is simply merge the pull request, and then boom, the GitHub workflow is automatically triggered, and you can see that it's built the image, sent it to the container registry, and now it's actually deploying those Kubernetes manifest files right into the cluster. So now we have a brand new cluster. We can actually take a look at some of the resources that it deployed. So we'll go take a look at the workloads, and then we can navigate down to our namespace, and then we can also check the services in ingress, and then click on the IP. There we go. We have an airline application that is ready to go, and that's basically the easy onboarding starting from 0 to AKS Automatic. Now, that demo is actually built using a feature of AKS called automated deployments, and that actually helps you auto-generate either Dockerfile or Kubernetes manifest, as I mentioned. The CI/CD pipelines will be in place so that anytime your developers commit code and push it through the normal PR process, it'll automatically deploy that to the cluster, right? And you can actually point it to any Git repo. Well, I shouldn't say any. GitHub or Azure DevOps, those two Git repos, and they can actually enable the continuous deployment into your cluster. But automated deployments actually does a little bit more than that, and I'll show you that in a second. The additional feature of AKS that we have is Service Connector. We all have applications that need to talk to other Azure services, right? And integrating your workloads in an AKS, integrating them and having them communicate should be simple. And with AKS Service Connector, it is indeed simple. This Service Connector actually integrates with 30 other Azure services, and the best part about it is that it can actually automate the entire workload identity configuration process for you. So if you ever done that on your own, federated credentials, service account, all that stuff, it'll do that so that your application can talk to other Azure services in a completely passwordless manner. So remember, kids, no passwords, no API keys, right? And this feature, along with ingress and TLS configuration, I think it ties really nicely into this other workflow that I'm going to show you. So here, I already have a cluster, but I don't have the application. So if you're going about it that way, you can literally just scroll down within the AKS blade and then click on the automated deployment section. Here, we're basically going to do a similar type of flow and setup, but pointing it to the cluster, configuring or pointing to our Docker file, setting the image name, right? The Kubernetes manifest. The thing that's really changing here is the service connection. So you can actually configure the service connector right here in this portal. So I'm using Azure OpenAI for a chat, travel assistant for my website. All I got to do is just point to the Azure OpenAI assistant, use my managed identity, and it's going to wire everything up for me. So that is really slick. The next thing that you will notice is like these environment variables that's in there, they're going to be automatically injected into the pod once it's deployed so that you have these configuration values already in there. The other cool thing that I mentioned is enabling the ingress. So if you're using AKS application routing and you have let's say a wildcard certificate in your Azure Key Vault, you can automatically configure all that. And in this case, I'm using Azure DNS for my website, and so I can just create a subdomain, and boom, application is in GitHub, and now is fully configured. CI/CD pipeline, configured to talk to OpenAI. I have a DNS, I have the TLS, and it's all good to go. So if I just click over to services in ingress, and I pop over to the ingresses tab, you can see that my subdomain is there. Click on that, TLS is all working, everything is good to go, and Azure OpenAI completely works. So that's pretty cool. No passwords involved, right? And that's kind of like the beauty of it all. Just to round out the entire developer onboarding experience with AKS Automatic, we're pleased to announce a new app-centric way in deploying and managing applications in your cluster with AKS Desktop. AKS Desktop is actually built on top of open source project called Headlamp, which was developed at Microsoft and donated to the CNCF to serve as the Kubernetes native UI, or user interface. With this new offering, the perspective changes just a little bit, shifting the focus away from the cluster and more so to the applications, allowing developers to quickly auto-generate and deploy apps and observe them with all of the monitoring hooks that AKS Automatic just provides for you out of the box, right? So faster time to business value there. Let's take a sneak peek at what this actually looks like. So this is actually a user interface. If you've used Headlamp before, it's very similar. And what you would do is you would actually configure a project. This project is actually a managed namespace, which I'll talk about in a second. But you just create the project name, connect to the cluster, and then you can set the network policies and also the resource quotas, right? So CPU memory quotas. Once you have the project successfully created, now you can start deploying your applications. And here I have a container image that's hosted in GHCR. I just drop that in, and then I can configure some additional settings around my application, around resource limits, and of course the ingress, how I want it to scale, and things like that. And then there you go. We get another auto-generated Kubernetes manifest file, which is really cool. Once you click deploy, that stuff just automatically goes out to your AKS Automatic cluster, and now you have immediately a dashboard that you can kind of click as an overview, view the metrics, telemetry, and of course it's based on Headlamp, so you get this nice, cool UI that kind of shows all of the different things that's going on in the Kubernetes world. And then, of course, you can start to interact with your application almost right away. Now, Amanda, that takes care of a lot of the day one, day zero, day one, day two activities. Is that it? Is AKS Automatic feature complete?
Yeah, no, actually. So as we have recently announced the general availability of AKS Automatic, we're continuing to listen to feedback from our customers and also make improvements to the product itself. So today, I have a very exciting announcement. Today, I'm excited to announce the public preview of AKS Automatic with managed system node pools. What this does is now AKS is actually managing the system node pools as well as all the system components that run on the system node pool on your behalf. By taking ownership of the system node pool, we eliminate common failure like add-on scaling issues and quota surprises when you're creating a cluster or upgrading a cluster. And with managed system node pool, you get predictable behavior for core services and fewer incidents that are tied to misconfigurations, helping you improve your day-to-day operations. Security is also built in. Since system components are now abstracted away from your subscription, there's no risk of accidental or intentional tampering with the system node pool resourcing, and which could affect your workloads. So some of the security restrictions that we have include preventing you from changing the system resources on the managed system node pool or deploying your user workloads onto the system node pool. By doing so, these core components that your workloads depend on can actually now run in a dedicated environment that's managed by AKS without being impacted by application changes or misconfigurations. So let's
dedicated subscription, does that mean I need to pay for that?
Yeah, so as we'll see in this demo, these managed system nodes are actually not going to show up in your customer subscriptions, but they're indeed running in the AKS subscription. So what that means for you is you don't have to pay for them since they're not in your subscription. So let's take a look and see this in action. So here I have an AKS Automatic cluster with the managed system node pool feature enabled. And when we switch to the MC resource group of this cluster, we can see a bunch of different Azure services that are deployed to make the AKS cluster run successfully. When we take a look at the virtual machines, we actually only see 2 user nodes, which are the AKS default node pools managed by node auto provisioning. And we don't see any of those system nodes, which are now abstracted away from your customer subscriptions and running in the AKS subscription. So what this means for you is now you don't have to pay for them or manage them. So when we try to get access to the system node pool, we can see that this should throw an expected error, and you're not allowed to modify or delete this node pool. So let's try to delete it. And we can see because the system node pool doesn't exist in your subscription, you actually can't get to it to mess with it and cause any kind of issues. So now through K9s, through the Kubernetes API, we actually see 5 whole nodes running on the system node pool, as opposed to earlier when we only saw the first 2 user nodes in your own subscription. The last 3 nodes here are actually the system node pool that AKS is provisioning on your behalf and managing for you. When we click into one of these system nodes, we can see a bunch of these system components and system add-ons that are running in the system node pool. And now all of this is taken care of for you by AKS to help reduce some of the misconfigurations and day 2 difficulties. So now as you start to deploy more workloads to your cluster and get your cluster ready for production, scaling becomes top of mind for you. Within AKS Automatic, we actually have 3 different scalers built in within the cluster. The first one here is node auto provisioning, which is using the open source project Karpenter. Node auto provisioning is special because it's able to pick different VM SKUs and mix and match them and place your pods into these nodes based on what the pod needs. So as you deploy more and more workloads, node auto provision is able to very intelligently place those pods into those nodes to help do bin packing, help do optimization, and help you reduce cost. The second scaler we have here is vertical pod autoscaler, which is able to increase or decrease the pod size dynamically as you deploy more workloads, and it takes in account of historic usage metrics to adjust those pods on the fly. And the last scaler here is the Kubernetes event-driven autoscaler, or commonly known as 𝗬𝗲𝗍𝗳, which uses different metrics that are built in to do the scaling. So if you have metrics coming from backend services like Redis Cache, Kafka, etc., or other metrics-based using your monitoring solutions like Azure Monitor or Prometheus, all of those scalers give you input for 𝗬𝗲𝗍𝗳 to do that scaling. And underneath the hood, 𝗬𝗲𝗍𝗳 uses horizontal pod autoscaler, which creates or reduces the number of pods to help you scale your application on the fly. And one thing that's unique to 𝗬𝗲𝗍𝗳 is its ability to scale down to 0. So if your cluster is not seeing a lot of traffic, again, that helps you do that cost reduction on the fly. So now let's take a closer look at the node auto provisioning feature. So like I mentioned, this is using the Karpenter project underneath the hood. Compared to the more traditional, well-known project like Cluster Autoscaler, node auto provisioning is different in a few ways. With Cluster Autoscaler, you have to create a node pool of a dedicated VM size before you even deploy any workloads. So at that time, it can be kind of hard to understand how big of a node do you need. While Cluster Autoscaler has scaling capabilities built in, it can be difficult for Cluster Autoscaler to do further bin packing, as it's only able to create more or fewer nodes of the node pool for that exact VM size that you specified at the beginning. But for node auto provisioning, as we can see on the left, there's a lot of different workload pods, and those get really bin packed into different kind of VM series on the right. So by taking a look at these workload pod requirements, these nodes get bin packed into these nodes. And as you deploy more workloads or node auto provisioning decides to scale up and down, that bin pack continues to happen. And one other unique thing about node auto provisioning is it can also take recommendations from you based on exact VM series that you want to use. If you purchase a reserve instance plan or savings plan of a specific node series, if you want to use GPU nodes, all of that you can specify with node auto provisioning, which it will take care of the bin packing for you and the scaling for you. So now Paul will show us how node auto provisioning plays this game of Tetris in real time.
Sure, yeah. So let's take a look at this recording here. So we're going to demonstrate how these two scalars kind of work in conjunction with each other. And so I'm just going to pull up two different terminal UI tools. So one is K9S, just to kind of see the number of pods that we have running in the cluster. And then the other thing is this AKS node viewer. This allows us to see the list of nodes that are currently running in the cluster. What I'm going to do is I'm actually going to use Azure load test to test the sample workload in the cluster. And the load test is fairly simple. I'm just going to send a pretty decent amount of load to it. So 1,000 users, we're going to ramp up 100 users per minute. And we're going to run this load test for about 15 minutes. Once this test is actually running and we flip back over to the terminal UI, you'll start to see that, 𝗬𝗲 sees that the number of requests or the pressure on the pods is pretty high, and so that we need to scale out more pods. And so what happens when we scale out more pods? Well, we run out of room on the cluster. And so that's when the node auto provision kind of kicks in, and then you'll start to see this long list of clusters kind of come up to kind of like deal with the scheduling of those pods. And if you kind of notice in the list of VM SKUs there, they are kind of different, which is a whole lot different paradigm than what the traditional cluster autoscaler did for us. And so once the cluster kind of fully scaled out, you really saw that the number of errors really dropped down because now we can handle that load. And then once the load test actually completes, 𝗬𝗲 says, yeah, I think we're good. We're going to start to compress down the number of pods. And then naturally, the number of nodes also falls. So it's a cool, different way of cluster auto-scaling. So that's neat.
Hey, Paul, did you notice any of those pods taking longer than 5 minutes to come up?
Actually, I didn't, no. No. Do you have something you need to tell us?
Yeah. So today, I'm excited to announce a major milestone in how AKS supports your application. AKS Automatic will offer a new financially backed SLA that guarantees pod readiness within 5 minutes at the 99.9th percentile for all AKS Automatic clusters by default. If the pods don't come up within 5 minutes, you get your money back. Most managed Kubernetes service, including AKS up until now, have only offered guarantees on the uptime of the control plane or the API server. While that's important, it doesn't directly translate to your application being up and running. When you deploy an application, every second counts. This is the first for managed Kubernetes. AKS Automatic is citing a new standard for what customers should expect from cloud-native platforms.
Did you say if it doesn't come up in 5 minutes, I could come look for you?
Yes, give me a call.
I'm gonna hold you to that. Okay. Going back to that load test demo, you might have noticed the number of nodes that got provisioned. It was quite a lot. And I think there was easily over 15 or so. What if that was your dev team working in a non-production environment? You probably don't have an unlimited budget, and you probably don't want to let your dev team kind of run wild and spin up as many nodes as they want. You do want to put some guardrails around that. And that's where this new service, Managed Namespaces, which is now generally available, might come into play. Managed Namespaces is basically the concept of multi-tenanted Kubernetes cluster with namespace isolation, but kind of surfaced up at the Azure control plane level. And so using Azure Managed Namespaces, you can effectively carve out little slices of your AKS cluster and assign them to your development team. And let's take a look at that right now. So in the Azure portal, you can actually just do a search for, oops, I didn't click play. So in the Azure portal, you can actually do a search for Azure Managed Namespaces, right? And all you need to do from that point is basically connect to an existing cluster. And you have the option of either creating a brand new namespace or an existing. And in this case, I'm going to take my existing namespace, team 1, convert that to a managed namespace, and then assign the RBAC to that team that's managing the overall namespace there. From there, you configure the network policies and the compute quota. Does this look familiar to what AKS Desktop was doing? Same concept. Fill in the labels, fill in the annotations that will automatically get applied to any of the Kubernetes resources, and off you go. That team now effectively has like a little slice of AKS that they can work out of. And the cool thing is that inside the portal, they have access to the things that they need access to. It's not the full AKS portal. You do get to see workloads, service ingress, configuration, and most importantly, service connectors, so they can actually connect services with their workloads. So that's really cool there. Now, The next question might be, okay, fine, I gave my dev team a slice of AKS with the managed namespaces. How do I ensure that whatever they deploy is compliant to organizational policies and best practices? Well, AKS Automatic ships with deployment safeguards just out of the box. These are effectively guardrails that enforces Kubernetes best practices inside your cluster from day one, right? And with this enabled, the baseline Kubernetes pod security standard is enabled and enforced out of the box, so you can add that on top of additional best practices and safeguards that your organization already enforces. The cool thing about this is that it's actually integrated with Azure policy, so you can assign it from the policy level, view it from the policy level, but it actually goes all the way down into cluster resources. And I can actually show you that right now. So I'm just going to flip over to my live cluster here, and I am connected to it. And you can see this is not the best YAML in the world, right? Oops, come on, I don't want IntelliSense popping up. Okay, I already have squiggly lines, so this is already not the best. I have Nginx latest. This is not cool. So I'm just going to try to apply this. And if I wait for it to talk to my cluster, boom, 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 boom. There we go. So the thing that came back was, yeah, forbidden. Sorry, Paul, you can't deploy this because, oops, hold on. I gotta scroll back up. It says here, you can't deploy this because of a admission webhook. So basically, deployment safeguards is actually built using open source project, the Open Policy Agent, and it uses gatekeeper constraint templates and constraints. So that's actually deployed into the cluster. And so it's actually validating as you're submitting things to the API server. And so in this case, I can't deploy this because it's missing or it's violating a lot of the policies. Now, if I change this to something better, like this, right? So now I have an Nginx and I'm using a specific container image version, and I'm setting the resource or the compute quota and the limits, and I have liveness and readiness probes. You know, some of the best practices that you should have. If I do this, oops, come on. What happened? All right, let's get a new terminal. Terminal doesn't want to load. Okay, here, I'll just run with this one. Okay, apply. I must have hit some key combination. Oh, sorry, forgot to save. Boom, click apply, and this should go through because now I have all the best practices already put in place. Now, that's down at the cluster level. This is how you could control how your developers are actually deploying into the cluster. How do you view it? So viewing the status of it is easy as just hopping over to Azure Policy. From the policy window, just click on compliance, and once this loads, there we go. I have good news and bad news. One cluster is compliant, one cluster is not. So let's take a look at that. Let's take a look at the good news first. So there's a lot of policies that are incorporated into this initiative if you've dealt with Azure Policy before. And so if I expand this out, there's a lot of like best practices that we enforce at the control plane level and just make sure that we have all these in place. And let's take a look at the cluster that is out of compliance. So if I look over here, it shows you that, so this policy is in violation. So container images using the latest tag, if I click on that and I dig in just a little bit more, I can view the details of it. Click on that. And then, once it loads, eventually, I saw a flash. There we go. So it actually pinpoints exactly which container images are in violation. So all of these, they're using the latest tags, and that just does not fly. So with that in place, you can actually use Azure Policy at the high-level control plane view and immediately enforce compliance into your development team's clusters. And you can ensure that you stay compliant without any manual checks, okay? So, oops, let me switch over here. There we go. So that was the deployment safeguard demo. Now, what is day two operations without observability? In AKS, onboarding observability tooling has never been easier. In the opening demo, it was like really simple. You just kind of go through the AKS creation process, and that stuff was already there. I just had to review it, right? Good news is that you get a similar process in your existing AKS clusters. Bad news is that you have to maybe click twice. So with just a few clicks, you can actually configure logging with Azure Log Analytics, metrics with Azure Managed Prometheus, and application monitoring with OpenTelemetry. The OpenTelemetry integration is pretty cool because you can auto-instrument your applications with 0 coding changes whatsoever. And the auto-instrumentation feature actually leverages Azure Monitor Application Insights, and it actually works by auto-injecting Azure Monitor App Insights OTel container image directly into your pod. It currently supports Java and Node.js with Python and .NET coming soon, so be on the lookout for that. Let's take a look at what this onboarding experience looks like and how you can auto-instrument your application. So head over to your AKS cluster. You'll notice that the monitoring blade has been moved up in the list of menus. Just click on monitoring settings. That's literally it. And then you just check a few checkboxes. Notice the enable application monitoring feature. This will actually enable auto-instrumentation for you. Wait a few minutes for that stuff to complete. And then at that point, all it is just going into your workload and configuring the auto-instrumentation, right? So that's all enabled. We are good to go. Now, you can actually configure auto-instrumentation at the namespace level, but you can also configure, if you want to be a little more granular with it, down at the workload level. So I clicked into my Contoso Air application, and then there we go. The application monitoring button is there. From there, you just point to your App Insights resource. You select the language that is written in, and then, of course, you just check the checkbox to redeploy your application pods. And then pretty much auto-magically, with no coding changes, you now have full telemetry inside of your cluster. You can see the dependency and the metrics and all that other good stuff. So jumping over to application insights, you can check on the application map. You see the main application. And then once I start interacting with the application just a little bit more, you'll start to see like the dependency tracing and things like that. And then now, boom, I can see my Azure OpenAI calls, and I can start tracking the performance on that. So that's really cool. The next thing that we are happy to announce is the general availability of Azure Monitor dashboards with Grafana. I know that's a mouthful, but basically, you don't have to provision Azure Managed Grafana on your own if you don't want to. Grafana dashboards are just available inside of your AKS cluster, and you can use it just like Azure Managed Grafana. So let me show you that. So if I go back to my AKS cluster and I choose that, hopefully the internet is decent. Scroll down to dashboards with Grafana, and this is all the same things that you had in Azure Managed Grafana. The only caveat being that dashboards with Grafana, it only accepts Azure data sources. But other than that, the UI is very similar, right? So all the dashboards that you are accustomed to seeing in Azure Managed Grafana, they're all here and just available out of the box. If I go back, if you have any, if there's any community dashboards that you typically use, you can literally just import the URL or the ID or even drop in the JSON, so you can actually do that as well. If you're like a PromQL person and you just want to write your own queries, just change the data source, and boom, there you go. You can automatically start using these resources, and the best part is you don't have to pay for anything. Okay, so that was the demo. And hopefully with all that, you kind of understand how AKS Automatic allows you to achieve more with Kubernetes and with less overhead, right? And in the era of AI, we really need to start focusing on innovating and shipping fast, and AKS Automatic is the right platform for that. Now, speaking of focusing on AI, self-hosting models in the cluster has become a necessity for some organizations for compliance reasons, or even just keeping a tighter developer feedback loop. One of the emerging tools that's starting to bubble up is this tool called 𝗦𝗲𝗀𝗀𝗶cie, which is basically an acronym for the Kubernetes AI toolchain operator. This thing is a Kubernetes operator that automates tasks like GPU provisioning, configuring, downloading of these open source models in containers, and giving you an OpenAI compatible endpoint, right? So applications that you write using OpenAI SDK, you can just snap 𝗦𝗲𝗀 right into it, and then it all works from there, right? It does a little bit more than inferencing, though. It can also do fine-tuning and support end-to-end RAG pipelines. So it's a highly capable and versatile tool. Now, this operator is available as an open source installation, so you can literally just do a Helm install, but it's also available as an AKS add-on, which means it's fully managed by the AKS team. So that's always cool. So Amanda, I think this is all game-changing stuff. What do you think?
Yeah, so we talked a lot about AKS Automatic today. To give you a quick recap, AKS Automatic is production ready out of the box with all these different features pre-configured for you based on best practices that we think you could really benefit from. And secondly, AKS Automatic really help you reduce your operational overhead with features like managed system node pools and all the built-in features within AKS Automatic. It helps you focus on developing your applications rather than managing the Kubernetes infrastructure. And third, AKS Automatic has a lot of different built-in scaling methods. So things like node auto-provisioning, which I touched on earlier, helps you do intelligent scaling of your applications. And as you deploy more workloads, that helps you to continue to bin pack those workloads and help you reduce costs. And lastly, today I announced an industry-first SLA, which guarantees the pod readiness within 5 minutes. This is a financially backed SLA, which means you get your money back if your pods don't come up. And this is in addition to existing SLAs that we already offer to guarantee the uptime of the platform itself, including the control plane and the API server. So both of these things come together to really guarantee you the success of your applications so you can trust on us. So to stay in touch with AKS and all the different things that we're doing, you can check out these resources where we regularly engage with customers and partners like you. Feel free to take a picture here. You can learn more about the behind the scenes of AKS through our YouTube channels, through our blogs, and also share your feedback with us through our GitHub pages.
Cool. And I guess on that note, in terms of like resources, if you're just getting started with Azure, we do have a program called Azure Accelerate, which can actually help connect you to experts, specialized partners, and even Microsoft funding to help you with your cloud adoption journey. If you go out to the hub, you'll see people in like blue jumpers with Accelerate on them. You won't miss them. Just tap their shoulder and ask them what's going on with that program and see how they can help you with your adoption journey, okay? Of course, if you are more of a self-learner type person, there's always resources out on Microsoft Learn, so that will take you out to a Kubernetes like tutorial, so that's always good stuff. And then I did mention a few things during this talk. You might want to check out some of these related sessions. So BRK120, that is actually talking about how M365 team, so they'll be in the house and they'll be talking about their journey with AKS, so that would be super relevant there. The other thing is BRK, I should mention that BRK120 is actually in this room tomorrow. Can't remember the time, so you might have to consult the schedule for that. BRK117 is all about AI inferencing, local models, 𝗦𝗲𝗀𝗀𝗀𝗀 included, so you might want to check that one out on Friday. I don't know where that one is at, to be honest, but yeah. And then there's a lab going on tonight, I think around 6 p.m., and it's all about migrating your legacy application into AKS Automatic with GitHub Copilot for app modernization. So that's going to be some really good stuff there. And then, of course, we have a few additional resources for you. So with that, that's all we have. So thank you for your time and attention. It's been a blast. We'll stick around a bit for answering any questions. And come find us at the AKS booth. So, yeah.